हेलो। हेलो हेलो। आवाज आ रही है क्या मेरी? Let's just check once. हेलो हेलो। हेलो।
हेलो।
ठीक है। लेट्स गो। कल तक अपन ने एंड क्वीन कर लिया था, अभी सुडोकू सॉल्वर। Write a program to solve a Sudoku puzzle by filling the empty cells. Must satisfy all of following rules. Each of digit must occur only exactly once in each row, exactly once in each column, exactly once in 3 by 3 grids. मेरा बोर्ड होगा इस टाइप से। Input board is motion where solution is shown below. Solve a Sudoku puzzle by filling the empty cells. This I haven't solved. No, I haven't. Board dot length is 9. Scan it into the input board has only one solution. I'll need a copy for this. Sudoku solve करना है. How do I normally solve Sudoku? I see what all is given. What can come here? So how did he come? Only option is 1, 2, 4, 7. मतलब 1 2 4 7 ही आ सकता है इस सेल पे. सॉल्व फ्रॉम 0 से स्टार्ट करूँगा. Why is it character? Oh, okay. I have to iterate for every row and every column. If I start from left top corner, I have two options. एक तो right जाओ या तो down जाओ. Right जाने पे solve करना है, down जाने पे solve करना है. दोनों अगर नहीं हुए then this will be a third of 2 comma column not equals to अभी मेरी करंट वाली वैल्यू पे डॉट नहीं है that means I have to fit one number. If this number is safe to be put here, then I will put the number here. How do I अरे यार बोर्ड को सेट कर देंगे, बोर्ड पे वो वैल्यू चिपका देंगे एंड देन आई विल सॉल्व फॉर same row column plus 1 and I will give it a board. जहाँ पे 9 होने वाला है तो मैं प्लस 1 को 0 पर सॉल्व करूँगा. अगर सेफ है वहाँ पे वो नंबर रखना है. Then I will push it. नंबर वहाँ रख दूंगा. सॉल्व करूंगा नेक्स्ट वाले के लिए. ब्रेक की कब से होंगे. I don't think you really are taking anything. I don't know what I've done. Let's see. Is my stream running? Yes, it is running. You कौन लिख I am in नशे में. I am not gonna change this code here, so I will put a const. And then I will give int row and column and इस फंक्शन में मुझे क्या लिखना है कि मैं क्या इस बोर्ड पे आर कॉमा सी वाली प्लेस पे वैल्यू को पुट कर सकता हूँ. तो मैं कब नहीं कर सकता हूँ. मैं तब नहीं कर सकता हूँ if this row contains if not. If it is less than equal to 2, then it is 0 or 2 if it is. ग्रिड मैप बोल देते हैं. 0,1,2, 3,4,5, 6,7,8. अब मेरे पास दो वेक्टर हैं क्रॉस देखो कॉल 2,4 का लेते हैं तो रो हो गया 0 कॉल हो गया 1 तो मुझे जो आई है 9 नंबर है ना मुझे कौन से वाले का देखना होगा 2,4 जितना है 2,4 इधर रहेगा 0,3 this will be grid of row grid plus I call grid plus I row grid is 0 1 call grid is 0 तो 0,1,2 होगा क्या होगा call grid is 1 मतलब 0 grid plus 0,1,2 Listen, portfolio, entropy, grid of grid of power plus enter 0 plus 1 is grid of देखो बोर्ड के होंगे दो आई और जे है ना ith क्या होगा रो ग्रिड का ith इंडेक्स ग्रिड ऑफ What is its time complexity? What am I doing? 9 क्रॉस 9 के लिए 81 टाइम्स। सर उसमें क्या कर रहा हूँ मैं? लेकिन वेदर इट इज सेफ मेरा इससे नो वैल्यूज रखने के लिए 9 क्रॉस 9 क्रॉस 9 क्रॉस सेफ है कि नहीं, सेफ है कि नहीं कैसे दिख रहा हूँ? 9 फिर ये ऑफ 9 तो ऑर्डर ऑफ 9 हो गया कांस्टेंट टाइम ऑर्डर ऑफ 9 एंड देन रिकर्सिंग एट मैक्स कम तक जाएगा 9 क्रॉस 9 बार still it is constant time isn't it? Constant होगी 9 amazing number of empty cells 9 की पावर m
Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So today we will be solving the problem Sudoku solver from the SD sheet. So what does the problem state? Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So today we will be solving the problem Sudoku solver from the SD sheet. So what does the problem state? The problem states that you're given a Sudoku puzzle. Now you must be knowing Sudoku puzzle. If you don't know, I'll be telling you. Don't worry about that. So you will be given a incomplete Sudoku puzzle. Now a Sudoku puzzle can have multiple answers. The task is very simple. Like you can see this this one is a 3,3. This orange one is a 3,3. This blue one is a 3,3. This ones, 6 ones, every possible way, right? So since I know I have to fill digits 1 to 9, so why don't I try out all possible that's in this row? Cannot. Can I fill up a 4? Yes. Yes, I can. Why? If you carefully observe, this 4 is not in this entire column, neither in this entire row, nor in this sub board. It is not there. So I can definitely fill up a 4. So I can say that can be another possibility check, which means one more recursion call. So let's try that out. So I can definitely fill up a 4. Now there are two possibilities as of now, as I can see. Can I fill up a 5? No. Can I fill up a 6? No. Can I fill up a 7? No. Can I fill up a 8? No. Can I fill up a 9? No. So what I see is, in this index, I just have two possibilities. One is filling up a 1. The other is filling 4. So which recursion will be called first? Obviously this one. And this recursion can wait because I know if I linearly iterate, first I will fill up and I'll call this recursion. When it comes back, then I will try to fill up 4 and I'll go to this. So let's perform this recursion. So I filled up 1. Now I will again try to fill up a 1 and you call the recursion again. So let's call the recursion again by filling up the 1. Java, both are same. So I'll be explaining you the C++ solution, whereas I'll be leaving the Java solution code link in the description. You can check it out. And the reason I'm doing this is because the videos are becoming extremely lengthy, and that is something which I want to avoid unless and until there's a question like binary tree or something. Then it really matters that I give both the solutions, right? So let's move on to the solution. And to understand the C++ code, so what we are given is a vector of char of boards. So basically this board is containing characters, and since it's we know that it's a 9x9 board, so that's a lot of places will be unfilled. So what I do is I call a recursive function. Yes, I call a recursive function, and what I simply do is I pass on the board function. I just pass on the data structure board that is given to me. Now in this function I've written a boolean function. Why? I'm going to tell you. So what was the first thing that you did? So the first thing that I did was I tried to figure out which is the first empty, like which is the. So in order to understand this, what you have to do is you have to understand first and foremost that this guy is 3 rows. Like this is 3 rows, this is 3 rows, and this is 3 rows. Like you just need to understand this. This is 3 rows. And in order to find column, let's understand the column. Do the same thing in column 2 because everyone do a modular 3. It's just do a modular 3. I'll tell you the reason of modular. Don't worry. So you basically get it as 6. So you get 3, 6 as your first guy, which is nothing but this guy. So when I is 0, you have checked it, right? Now this guy stays constant. This guy stays constant. If it contains 1, so you can say filling up this 1 is not possible. So in this way, you can definitely check for the entire row because only the I is fluctuating. The row is constant. Can I similarly do for the column? Can I say it's this one is let's say this is having a 1. So can I say this one is 0, 7, 1, 7, 2, 7, 3, 7. I can basically talking about indexing. So can I say the row is only increasing? So why don't you check it? So if I check board of I and column stays constant, if it has 1, I can definitely not fill up 1. So in this way, in a single for loop, can I check the entire row as well as the entire column? Yes, I can definitely. So I made a single for loop where I'm able to check the row as well as the column in a single instance. But can you check this submatrix is my straightforward question. And the answer to that is yes. So now it's time to understand how do you check this guy, right? So in order to understand this, what you have to do is you have to understand first and foremost that this guy is 3 rows. Like this is 3 rows, this is 3 rows, and this is 3 rows. Like you just need to understand this. This is 3 rows. And in order to find this first row, like in terms of I, it's a very simple formula. I'm going to tell you the formula. Currently, you are at 5, 7, right? You are at 5, 7. So what you do is 5 divided by 3, right? That gives you 1. multiplied by 3 because everyone is having a 3 length. So 5 by 3 will tell you, like, let's say this is the 0th horizontal, this is the first horizontal, this is the second horizontal. So 5 is over here. So 5 by 3 tells you to which horizontal does it belong. So 5 by 3 is basically 1. So it says that it belongs to the first horizontal, right? So if you multiply 3, because 3 is a single size, so 3 into 1 means this guy. So you get a row number as 3. So this is the row number that you get, 3. Correct, you got 3. Next, if you just do I is 0, and if you just divide it by 3, because every this length is 3. So every one is of 3 lengths. So if you divide it by 3, you will definitely get 3. So this is the first time you get the row as 3, right? What about column? Let's understand the column. Do the same thing in column 2 because everyone is of the length 3, correct? So try to figure out, like, this is the 0th guy, this is the first guy, this is the second guy. So to which guy does this box belong? Again, 7 by 3 will tell you now. So do a 7 by 3 and then multiply by 3 to get the first column. To get a first column, just multiply. So 3 by 7 will be 2. 3 into 2 will be 6, right? You're done. Now, simple. 6 plus I is 0. Just do a modular 3. Let's just do a modular 3. I'll tell you the reason of modular. Don't worry. So you basically get it as 6. So you get 3 comma 6 as your first guy, which is nothing but this guy. So when I is 0, you have checked it, right? Now, this guy stays constant. This guy stays constant. What changes is I. Next, I will change to 1, and over here I will change to 1. So what happens is 3 plus 1 by 3 still stays as 3, but 6 plus 1 modulo 3 becomes 3 comma 7, which is nothing but this guy. So you're checking for this. Next, I will become 2. So 3 plus 2 by 3. So that still stays as 3. And 2 modulo 3. So this becomes 8. So what are you checking? This guy, right? Next time, this becomes
No, I have attempted this in 2020, 2020 May, April and May. You are given an undirected graph consisting of V vertices and P edges, represented by this list edges, along with an integer m. 0 to 1 एक edge है, 1 to 3 एक edge है, 4 मेरे को vertex दिए हैं. Task is to determine whether it is possible to color the graph using at most different colors. It is possible at most. मेरे को m colors दिए हुए हैं. मैक्स इतने m colors यूज करते हैं such that no two vertices share the same color. मतलब मैंने जीरो वाले पे जीरो कलर रख दिया, तो उसके साथ एजेस किसके हैं, वन के हैं, थ्री के हैं, टू के हैं, मैंने क्या
Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So today we will be solving the problem M coloring of a graph. Yes, and this is from the SD sheet. So what does the problem states? The problem states that you'll be given an undirected graph, yes, and an integer M. Now your task will be to determine if the graph can be colored with at max M colors. Now that is the question. And whenever you're coloring the graph with M colors, you just need to make sure that none of the two adjacent vertices or nodes of the graphs are colored with the same color. Now, if you have seen my graph series, you would have seen the bipartite graph video. Over there, the question was, instead of M colors, it was two colors. So over here, we will be checking if the graph can be colored with M colors or not, right? So if it is possible, you just need to return a 1. And if it is not possible, you need to return a 0. That is the simple enough question. Now let's understand this question with the help of this graph. So imagine this is the graph, and I'm asking you, can this graph be colored with the help of 3 colors? And your answer will be yes, definitely. Why? Because let's imagine I say that I'm going to color 1 for this node, and I decide that I'm going to color 2 for this node. Okay. And after that, I decide that I'm going to color 3 for this node. Okay. After that, what if I decide that I color 2 for this? So if I try out coloring in this fashion, you see that none of the adjacent nodes, like for 0, the adjacent node is 3. For 0, the adjacent node is 2. For 0, the adjacent node is 1. None of them are having the same color. That is what the question stated. You need to make sure that the graph can be colored using at maximum of 3 colors. It's not a compulsion that you have to use 3 colors. It's just the maximum number of colors that you can use. So over here I can see with the help of 3 colors, I was able to color. But what if I take M equal to 2? Can I color it? Let's see. Imagine I color this with 1 and I decide to color this with 2. Definitely can I color this with 1? No. Why? Because this and this guy are adjacent. You can see that both adjacents are having colors 1. So definitely not. Can you color it with color 2? Again, no, because this and this are adjacent and they're having the color 2, same color. So using at maximum 2 colors, I will not be able to color this graph. So that is the simple question. Given M, you just need to tell us if you can color the graph with M colors or not. If you can, just return a yes. If you cannot, just return a false. That's the question. Projects. A lot of you actually struggle to find ideas about projects, isn't it? So what if I tell you an academy and coach are bringing up an initiative? So guys, I will try every color on every node. Think in this way. Try every color on every node. With the question stating. Definitely going to have a perfect Sunday. So guys, do check this out because it's going to add value. So how do you solve this problem? What is the question stating? Can you color this with at max M colors? So why don't I try every possible way? And you know that if I am going to try every possible way, the best way to implement that is using recursion. So why don't I do that? So the recursion thinking should start in a way that I will try every color on every node. Think in this way. Try every color on every node. And since I have 4 nodes, these are 0 based indexing. So imagine I start up with the node 0. And what does recursion means? Tries every possible way, right? So what is the possibility of coloring this node 0? So you might be like, hey Trevor, why don't we color this with the color 1? I agree. Why don't you color that with color 1? So assume I color that with color 1. Now you might say, hey Trevor, why don't you color that with color 2? I agree. Yes, we can. Now you again might say, why don't you color that with color 3? I'm agreeing to every step that you're saying because we can definitely start coloring it with color 1, 2, or 3 because we're trying recursion. Recursion means try every possible combo. So in recursion, the first step that we will do is we will start coloring that with color 1. So why don't you color that with color 1? Okay, so just start with color 1. And if this is successful, if I start with color 1 and that comes out to be successful, so there's no need to try out other colors. This is the possible answer. Now, since I've colored the node 0, now instead of traversing on the graph, we know there are 4 nodes. Let's travel the 4 nodes individually. So what is the next node number wise? It's 1. So go to the node 1. Now I ask you a simple question. Which color can you color the node 1? So you're currently at 1, right? Now you might try out with 1 because whenever you're writing recursion, it tries every color. Now when you try out with 1, you see you can definitely not color that with 1. Why? Because the adjacent node of 1, that is 0, is having the color 1. So this is not possible. So when you tried coloring with 1, that's not possible. So what you decide is, okay, let's try with the other color. Can I color that with color 2? And you see that if you try coloring it with color 2, that's actually possible. Yes, that's actually possible. And if it is possible, I know there's one more color 3, but let's not try that as of now. Let's try out the next node in the serial wise. So the next node is node 2. Okay, so I go to node 2. Now, when I go to node 2, the first color that I will try is, because I'm trying every color, let's try out color 1. Let's check out can I. So when you try color 1, you see that 2 has an adjacent node 0. 2 has an adjacent node 1. So you can definitely not color with color 1. So color 1 is not a possibility. Now you decide, can you color that with color 2? So when you try that with color 2, let's see what happens. If you try that with color 2, it checks for its adjacent. 0 is the adjacent. It's having a color 1. Okay, fine. 1 is its adjacent. It's having a color 2. That's not fine. That means you cannot color with color 2. So that means we're left out with the next color, that is color 3. Let's see if we can. Just let's see if we can. So if I try to color this with color 3, can we? What are the adjacent nodes? 0, it's having a color 1, which is not 3. The other adjacent node is 1, which is having the color 2, which is not 3. So I can color with color 3. That's a practical possibility. And if it is in the serial wise, I move to the next node. Yes, you're going to move in serial wise. So when I move to the next node, I see that the next node is node 3. So again, I'm going to try out with color 1. Yes, I'm going to try out with color 1. So let's try out with color 1. So when I try out with color 1, I see it is not possible. Why? Because the adjacent node is also having a color 1. So coloring it with color 1 is definitely not possible. Can you color that with color 2? Let's check that out. I can definitely not, because the adjacent node is 1 and we cannot. So color 2 is also not possible. Can you color it with color 3? So I will be like, yes, yes, you can. So since I can, I try to color that with color 3. And after that, I move to the next serial number node, that is node 4. Now at this moment, yes, at this moment, we see that the number of nodes were 4 and you reach the serial number 4. And whenever you reach the serial number 4, that means, why did you reach here? Because every node you are successfully able to color with some color, right? You're successfully able to color it with some color. That is why you reach the last serial node, that is 4. Hence, I can say I was able to. So thereby you can return a true. Why true? I'm going to tell you. Over here, F3, which called F4, says you give me a true. So I'm going to return a true. F2, which called F3, returns a true. Now, do you remember on F1, you tried with color 2. So since you're trying every color, there could have been a possibility of coloring that with color 3. And you could have got one more possible solution, might be. You might have got one more possible solution. But the question stated, can we? The question stated, can we? So is there a need of actually trying out a color 3 on the node 1? No. So that's why returning a true is very important. So that if you got an answer by coloring with a particular color, you do not move to the other colors. So this returns true. So this guy gets a true. Doesn't try for other one and returns a true. And this guy tried with 1. Will it try with 2? Will it try with 3? Absolutely not. Why? Because when he tried with 1, he got possible solution. Hence, he got a true. So thereby, he also returns a true. Whenever this true is returned, your graph is definitely colored with M colors. So how will the pseudocode look like? So can I say I'm starting off with a node? So why don't I start off with a node? Okay. Now, what is my base case? So I can definitely say if I'm moving on serial number of nodes like from 0, 1, 2, 3, 4. So can I say if I filled up every node, I will definitely reach the node n. And if I reach n, that means why did I reach it? Because I was able to color everything. So why don't I return a 2? So I returned a 2, right? Now, if it is not n and if it is like 1 or 2, so in that case, what am I trying? I'm trying to color that, right? With what colors? From 1 to m is what I'm trying. Now, when will I color? You just saw, right? If it is possible to color that node, if it is possible to color, right? If it is possible to color that node, then I will color it. Probably you can maintain a color array, and you can say that the node color will be this color, right? This color. And after that, what did you do? You did call the function for the next node, next serial number node. So let's call it. And if this function returned a true, then did you try out the other color? Did you? No, you did not. So what you check is
चार नोड है which node it is and we total कितने nodes हैं I'm not gonna change this and colors. First of all, create size will be m, size will be क्लासरूम तक नहीं पहुंच रहे हैं। So I will for each color I will try to पहले तो सेट कर दूंगा। Let's set the color for this is I color कर दिया and then I will solve for n plus 1 and if it is ये सब करना जब it is possible to color nth नोड पे कलर्स है nth नोड पे ये सारे एजेस के साथ क्या मैं कलर कर पाऊंगा? अगर ऐसा है तो कलर कर दो then solve for edges and भी चेंज नहीं होगा। solve otherwise उसको solve करने में आंसर नहीं हो रहा है then I will revert it and then we go for next color we have to create a safe this will take what parent node where edges colors nth नोड पे कौन सा कलर भाई कौन सा कलर ith कलर nth नोड पे सी वाला कलर कर सकता हूँ क्या? कब नहीं कर पाऊंगा? जब मेरे इसके साथ जितने भी एजेस हैं देखो मैं 0 पे मान लो कलर हो चुका है तो 1 वाले पे अभी 1 के साथ कौन है 0 है 0 वाले पे कलर क्या है अगर वो निकला तो नहीं हो पाया लगता पलट तेरा ध्यान किधर है कल ये एज है ध्यान किधर है तेरा इधर है तो कितनी खबर वो है क्या किया, मैं सारे एजेस पे लूप कर रहा हूँ। अगर वो nth एज उसका पार्ट है तो क्या मैंने जो उसका पार्टनर का कलर सी है तो नहीं कर पाऊंगा, फिर वैसे ही इसमें कर दिया। ऐसा नहीं है तो मैं लेट्स सी, कुछ तो गड़बड़ हो गई भाई। edges of zero. Are we back? Yes, we are back. Okay. What is edges? Edges is a vector of vector. For each edges of I comma 0, ith edge पे मैं जाऊंगा, ith edge पे मैं जाऊंगा, ith edge पे मैं जाऊंगा, ith edge पे मैं जाऊंगा। एक बार सबमिट करके रॉन्ग आंसर इसको पूछते हैं। Very close structure is solid. There are a couple of subtle issues. You are initializing colors with size M. Should track the color assigned to each. Oh yes, भाई color should be vertices के लिए होने चाहिए ना, कि भाई इस वर्टेक्स पे क्या कलर डला हुआ है। Sold. Inefficient adjacency check. If you are scanning the entire edges which is essential. Build an adjacency list once and use it throughout. What is adjacency list? पूछते हैं। क्या हो गया भाई? Is a way to represent a graph using a collection of lists. हाँ भाई, दो तरीके से रिप्रेजेंट करते हैं, एक तो एरे जैसे और एक तो adjacency list. Especially efficient for sparse graphs because it only stores existing and can adjacency matrix stores on example 0 1 2 है, 0 1 1 2 2 0 adjacency list क्या होगी, 0 से कौन कौन जुड़ा है, 1 जुड़ा है, 2 जुड़ा है, 1 से कौन कौन जुड़ा है, 0 जुड़ा है, 2 ऐसा। What are ways to represent graph like adjacency matrix कि भाई 0 0 तो है, 0 से 1 के लिए एज है क्या, 0 से 2 के लिए एज है क्या, ऐसा। adjacency list 0 के पास 1 का एज है, 2 का एज है, edge list। For each edge, I will create U का V पे है, V का U पे है. Bro, easy. डिस्टेंस बना ली तो फिर उसमें चेक कर लेंगे. Let's check our old submissions. मैंने क्या किया है? 51 because why 51? Why 51? Is safe. अच्छा, पहले इनपुट भी हमें लिखना पड़ता था भाई. Sync with stdio field and टेस्ट केस नंबर कितने टेस्ट केस होंगे, सारे टेस्ट केसेस के लिए क्या क्या इनपुट होगा सब लेना है. फिर उसको डेटा को स्टोर करना है. देन कॉल योर सॉल्यूशन फंक्शन. भाई इतनी मेहनत करते थे. This was also a good question. मजा आया. ठीक है यार, अभी कल अपन रिकरेंट बैक ट्रैकिंग क्लोज कर देंगे. रेटिनोवेज और वर्ड ब्रेक बाइनरी सर्च और बाकी चीजें सॉल्व करेंगे. ठीक है. मैंने स्क्रीन शेयर ही नहीं की थी वापस. एक बार सोल्यूशन दिखा देता हूँ जस्ट. Oh, by the way, मेरा wallpaper. I just bought wallpaper engine. Solution दिखाने के लिए देखो मैंने क्या किया. एक कलर्स करके एक वेक्टर बना लिया दैट विल स्टोर कि कौन से वर्टेक्स पे कौन सा कलर असाइंड है. ठीक है. फिर मैं सॉल्व कर रहा हूँ 0th वर्टेक्स से स्टार्ट करके वी वर्टेक्स तक सारे वर्टेक्स पे कौन सा कलर चिपकाना है वो करूँगा. सॉल्व करते टाइम अगर मैं फाइनल वर्टेक्स पे पहुंच गया देन आई कैन कलर इट. और अगर कलर नहीं कर अभी तक कलर अब नहीं लास्ट पे नहीं पहुंचा हूँ तो मैं उस पर कौन सा कलर होगा वो ट्राई करूँ. सारे कलर्स ट्राई करने हैं. अगर मैं nth वर्टेक्स पे ith कलर डाल सकता हूँ then I will put that color and then solve for n plus 1th vertex and otherwise फिर बैक ट्रैक करने के लिए वापस सेट किया. सेव टू कलर मतलब कब हम कलर कर पाएंगे, जब ये जो एजेस है हमारे पास सारे एजेस पे लूप कर रहा हूँ और अगर उसका जिसके साथ एज है क्या अगर उस पर ये वाला सी कलर सेट है तो मैं उस पर कलर नहीं कर पाऊंगा. रिटर्न फॉल्स अदरवाइज आई विल रिटर्न ट्रू. ठीक है. तो ये था मेरा सॉल्यूशन. इट वाज अ गुड क्वेश्चन. कंपनी ट्राई करना सब. चलो गाइस, आज के लिए इतना ही रखते हैं. कर लिया यार. आई एम गेटिंग द हैंग ऑफ इट. चलो बाय.